Okay, class, I'm happy to see that everybody completed the do now and understood it well. Now we will move into today's lesson, and that will be about trapezoids and something called the median. So as you can see here, I have drawn a trapezoid, and this line MN is what is called the median. Now, there's two important characteristics about medians. Those two characteristics are that the median is parallel to the two bases. Okay, so it's parallel to here, SR and PQ. The next thing is that it'll be half the length of the sum of the lengths of the two bases. And today we're going to start by proving these two facts. So there are multiple ways to prove it, and I'm going to ask you guys to prove it on your own using techniques we've learned previously in class. Then I will go over it. Remember, there are multiple ways to prove this. So the way I prove it might not be the same way you proved it, but that's okay, as long as everything you used is stuff we've learned previously. So the way I'm going to prove it is I'm going to start by, I drew this imaginary line almost from point S through our median point N to a new point T. And what that has done is that has created two triangles here, one over here and one over here. Okay? And using the techniques that we learned previously about congruence of triangles, we can prove that the triangles are congruent through ASA. So our first statement will be that triangle TNQ is going to be congruent to triangle SNR. Now remember, the order of the letters matter here. I wrote T and Q, and in our congruence here, S corresponds to T, N corresponds to itself, and Q corresponds to R. So that order is very important. And our reason for that, as I just said, is ASA. Now, our second step after that is we can say that SN is congruent to TN. Why? Because we can say corresponding parts of congruent triangles are congruent. So in our two triangles, SN corresponds to TN in the other triangle. Now from there, we can say that N is the midpoint of ST, since SN and TN are congruent. So I will write N midpoint of ST. That is by, you can either, if we number our statements, we would say by statement number 2, or we can say by definition of midpoint, because that's what a midpoint is. Then, from there, we're going to use a theorem that we learned previously when discussing triangles. And this is going to be the triangle mid-segment theorem. So we're going to look at this big triangle mid right here, SPT. Okay? This big one. Go from S to P, down the leg of our trapezoid, all the way out to our new point T that we added for this proof, and then S. That's our big triangle. We're going to look at that big triangle as well as our median here. And if we look at those two things, we can say that MN, our median, is parallel to PQ, right here. Our first base by the triangle mid-segment theorem. Now I'm going to abbreviate. Let me write that better for you guys. Apologize. Okay? But if we say that MN is parallel to PQ, well then it's also parallel to SR because PQ and SR are parallel. So then we will write MN is also parallel to SR. This will be by transitivity. Yes, what's transitivity? Good question. If you remember, transitivity, to put it simple, is if A equals B, right, and B equals C, then A equals C. So here our A is MN, which is parallel to PQ, but then PQ is parallel to SR as part of our trapezoid. That means MN is parallel to SR. That was a good question. Next step will be to prove the second part, because in case now you should notice, we just proved the first characteristic of our median, that it is parallel to the two bases. Now we need to prove that it is half the length of the sum of the bases. But another thing that the triangle midsegment theorem is going to tell us is that MN is going to be half of PT. That is one other thing that the triangle midsegment theorem tells us, that it is half the length of PT. So our reason will be midsegment theorem. But what we can substitute something for PT. We can substitute PT is equal to PQ plus QT. And our reason will just be by algebra, right? But what can we substitute for QT here to make it relevant to our trapezoid? Yes, very good. We can say that QT is congruent to SR by CPCTC, because we're looking back at our initial triangles. These are corresponding parts here, QT, SR. Oh, my mistake. Remember, I said how we label is very important here. So if I write QT, I have to write RS. Good catch. So that means that we can write PT. Oh, I forgot the 1/2 here. We can write that PT is equal to 1/2 PQ plus RS. And that's by substitution. And now we have proven the second part of our proof about medians. Oh, sorry, I apologize. I made a mistake in my writing. Good catch. Whoever shouted that out, I'm sorry, I didn't see. Good catch. This should be MN. MN is equal to 1/2 PQ plus RS. MN is our median. It is equal to half the sum of our bases. Very good. Now that we've proven that, we're going to do an example together. Is everybody done with their proofs? Does anybody have any questions? Does anybody need to finish copying down the proof that I have done for you guys? No? Okay, thank you. So I'm going to erase this, guys. We're going to move on to an example. An example will be a very simple trapezoid that I will draw. Please excuse my bad drawing. And I'm going to label it here. This is going to be 10. This is going to be x minus 3. This is going to be 2x minus 4. So we're looking for x here. So our first step is going to be to write that 10 equals 1/2 base 1, x minus 3, base 2, 2x minus 4. Okay, now we can simplify by, we can get rid of our half, make it easier numbers for us. If we multiply by 2, we get 20 is equal to, and then in one step we will simplify what is in our parentheses. We have x plus 2x, which is 3x. And then we have minus 4 and minus 3, which will give us minus 7. And by solving for x, we can get plus 7 plus 7. 27 is equal to 3x. We divide by 3, and x equals 9. Did anybody struggle with that? Does anybody have any questions about that? Okay, very good. Next, I have a little riddle for you guys to test if you were paying attention on these trapezoids. Now that for you is, can we have a trapezoid that has 3 acute angles? 3 acute angles. Yes. Very good. It is impossible to have a trapezoid with 3 acute angles, because with any trapezoid, as we learned when we discussed regular trapezoids yesterday to begin with, we have, if we label these angles 1, 2, 3, 4, we have that 1 and 4 are supplementary, just like 2 and 3 are supplementary. So if we have 1 being acute and 2 being acute, well, 3 and 4 then have to be obtuse for it to be supplementary. So we cannot have 3 acute angles in a trapezoid. Now, can anybody tell me if they believe a trapezoid can be classified as any of the other quadrilaterals that we've learned this year? Yes. Very good. The answer is no. A trapezoid is not classified as any other type of quadrilateral. Okay? It can't be a parallelogram. It can't be a rectangle, a rhombus, a square. A trapezoid is on its own. So, lastly in class, we're going to take example 1 like we used, and you guys are going to pull up the written exercises, okay? I uploaded the paper for you guys on Google Classroom, but also it is page 192 in our textbook, if you need to access it that way. And I'm going to ask you guys to do problems 1 through 9 in groups. Okay, very good, guys. So we've hit the end of our class. We ran out of time, so we will go over the written exercises 1 through 9 tomorrow to begin our class. And for homework, I'm going to ask you guys to complete the assigned practice worksheet that I have uploaded to our Google Classroom for tomorrow's class. Now, if you guys need any help, I have uploaded a YouTube video if you need it. And if you guys would like to reteach yourself with more problems, I will upload a reteach paper for you guys to reteach yourselves if you wanted more practice or needed to look over the proof again. Okay, I'll see you guys tomorrow.